Hello students, in this video we have 12th example of chapter 4. Three different situations we are given and we are asked something for this three different situations. In first one, we have a current carrying circular loop lies on on a smooth horizontal plane. Can a uniform magnetic field be set up in such a manner that loop turns around itself? That is turns about vertical axis. First question. So let us first understand first question, then we'll go to second one. So consider a circular loop. Say this is circular loop and say it is carrying current. Now the axis is like this. So can we have some way of external magnetic field? Can we apply external magnetic field in some way that we can make it rotate, make this loop rotate like this, or maybe like this, that is about its axis. Now this is not possible situation. You may apply external field like this, nothing will happen, or else you may choose to apply external field in this way. Let me draw two separate diagrams. So the possible ways to apply magnetic field are, if this is loop, this is one way we can apply external field. It may experience torque, but if you want it to rotate about its axis passing through center, not possible. So in either case, maybe this one. So maybe in this case or in the other way, answer is 0. You cannot make it rotate through its vertical axis. Let us come to second question. A current carrying circular loop is located in a uniform external magnetic field. If the loop is free to turn, what is its orientation of stable equilibrium? Now, what do you mean by stable equilibrium? Stable equilibrium is the one in which loop will try to come back if it is disturbed. So let us consider two situations. This is the external magnetic field, and in this I am suspending a loop in this way. So this is the area vector and this is the external magnetic field. And then we consider another possibility where we have magnetic field applied, and now I consider loop to be like this. So what is the direction of area vector? It is coming out of the surface of screen. So B and A are perpendicular to each other. Okay, so now what is the difference between the two? Difference is in this case, in say figure 1, I have angle between B and A to be 0 degree, and hence this is the maximum stable condition for the coil. And what is the torque acting here? It is NIAB sine 0. So if you disturb it slightly, the coil will try to come back to this situation of theta equal to 0. So this is called stable condition. And in this case, if you allow some current to pass through it, magnetic field lines will be like this. Say this is the current direction and this is how we will have magnetic field lines. And what is the direction of external magnetic field? It is also like this. So I can say that the external field and field of coil both are in the same direction and resultant flux is maximized. So when the coil is in stable equilibrium, flux value increases, which is not the case here. In this case, the field lines of the coil may be like this and external field is like this. So flux value is not increasing. Let us go to third question. A loop of irregular shape carrying current is located in an external magnetic field. If the wire is flexible, why does it change to circular shape? So now the question is that sorry, what if I take magnetic field and what if we place a loop of irregular shape? Now here if you pass current, you will see that after some time it will assume circular shape. Very simple reason is whenever you have external field applied and current passing through the wire, the opposite elements like here if you consider this too, currents will be in opposite direction, isn't it? And hence these two parts, this part and this part, will oppose each other in terms of magnetic field and they have repulsion. So overall they will try to go apart, and circular shape is the shape where they can go to maximum distance. Area will be maximum for circular shape. So whichever initial shape you give to the wire, but if it is flexible enough, lastly it will assume circular shape because in circular shape area is maximized. So that is all about this three situation. I hope it is clear. Thank you.